Hi everybody, it's Peace Daddy. Today we are going to do a lesson on fractions. This is fractions part 2, and the first lesson in fractions part 2 is to make and explain equivalent fractions with attention to how the number and size of the parts differ. One of the terms that we're going to be talking about, and it should be a familiar term to you, but we're going to talk about it a little bit more, is least common multiple, or the LCM. And today I am going to be using pattern blocks. And I don't know if you have pattern blocks at home with you or not, but if you don't, there is a good website called Cool Math for Kids, the number 4, coolmath4kids.com, and /manipulatives/pattern blocks. And if you go to that website, there is a section with pattern blocks that you can click on, and you can manipulate the pattern blocks and put them on top of each other, just like I'm going to do today, so you can see the way that we can use that to help us with the least common multiple. All right, so let's take a look at what we're doing today. So on my rug, I am going to start out with a hexagon. So this is a 6-sided shape, and I am going to call this hexagon 1. It's going to be 1 unit. So what I'd like for you to do is use the trapezoids in the pattern block material and use the rhombi in the pattern block material and use the triangles in the pattern block material and see if you can make some equivalent fractions with those shapes. And when you're done, I'd like for you to draw and label your equivalencies. So, what do I mean by that? Well, I'll give you an example. The way that I would start is with the hexagon. And I would trace around the hexagon like this. Now this is after I've gone to coolmathforkids.com and done this with the manipulatives. So you can move this virtually around and then start thinking about, all right, so if that is equal to 1, then what is the next thing that I could do? Well, I could take this trapezoid right here and I could put it inside or on top of my hexagon like that. And look, it takes 2 trapezoids to fit right on top of my hexagon. And each trapezoid takes up half of the space. So if I put 2 of these together, it would make 1 whole. It would take up the exact same space that the hexagon takes up. So this must then be a half. So if the hexagon is 1, it means that the trapezoid is 1/2. And we need to think about how many trapezoids it takes to make a whole. It would take 2. So 2 halves would make a whole. Right? Okay, so now let's keep going, and I'm going to be thinking about these other pieces down here. So if this 1 hexagon again equals 1, now I'm gonna use this rhombus, and I'm gonna see if I can get it to fit on top of the hexagon. There we go. And then I'm gonna see if I can put another one on there. Okay, that looks good. And then I think the last one will fit just like that. So I've made another equivalency. Look, 3 of the rhombi make 1 hexagon. So that makes each rhombus worth 1/3 because it takes 3 of them to make 1 whole. So whenever you have something and it takes 3 of that object to make 1 whole, it means that it's worth 1/3 of the whole. So this one equals 1/3, right? Okay. And then the last thing I can do is I can see how these triangles will fit. So these little triangles are going to fit on the edges of the hexagon like that. And this one will fit over here. See if I can get how many on there. Looks like it's gonna be 6 of them. Isn't that interesting that 6 of the triangles fit on the 1 hexagon? So what does that make the triangles worth then? Well, if it takes 6 of them, then 1 triangle would be worth 1/6. So it's important to remember that 6 of these triangles are taking up the space of 1 hexagon. So I forgot on my rhombi that I need to write that that's also equal to 3/3. Remember, because 3 of these fit on my hexagon. So that each one is 1/3, but all together they are 3/3. Okay, so 1 whole is equal to 2 halves, which is also equal to 3/3, which is also equal to 6/6. So what's the rule about something being a whole? How can I write a whole as a fraction? Well, it looks like if the numerator and the denominator are both the same, like we have here, I have the same numerator here and the same denominator here, then that fraction is worth 1 whole. And I have the same numerator here and the same denominator here, they're both the same number. So this must be worth 1 whole. Same numerator, same denominator. Both those numbers are the same, so that makes 1 whole. So that's a good rule to remember. If my numerator and my denominator are the same number, then it means that that fraction is worth a whole. Okay, so let's try a couple of other things here. I'm curious if this trapezoid shape, this 1/2 shape that I used, can be made with the other shapes. So what do I mean by that? Well, could I get the rhombi to fit on there? No. See, there's not enough room, but what is that shape right there? That shape is a triangle, And so I know that 1/2 then is equal to what? 1/2 is equal to 1/3 plus 1/6, right? If this piece is equal to 1/3 and this piece is equal to 1/6, then I can put them on top of 1/2 and it takes up the same space. Then that has to mean that 1/3 plus 1/6 makes a half. Interesting, okay? So now let's try 1/3. Oh, I see this one already. Do you see it? There. And there, look. So that means that 1/3 is equal to 1/6 plus 1/6, which is how many sixths? 2/6. There they are. 1/6, 2/6. So 1/3 is also equal to 2/6. They're equivalent. So what about this? What if I put the sixths, oh I see, onto the halves? Look how that works. That fits. You see that? So 1/6 and another 6th and another 6th, 1, 2, 3 sixths also makes a half, right? So 1/6 plus 1/6 plus 1/6, which is 3/6, is equal to 1/2, right? And I don't know if maybe you could find some more. Maybe you could. I don't know if I've made all of them, but your notebook should start to look like this. And you know, when you're done, take some colored pencils if you have them at home, and you can go ahead and start shading it in just like that, right? And that's a good way to do this work. So the green one, the triangle would be green, so you can keep track of it that way. And the trapezoid would be red, so it matches. And make your hexagon yellow and color it in. And you can do this on a separate piece of paper and then tape it into your math copybook, or you can, you know, just write it directly in there. So what was our goal for today? We said that we were going to make and explain equivalent fractions. We're going to pay attention to how the numbers and the size of the parts differed. Well, did we do that? So it looks like, if I'm just looking at this one, for example, I don't know why I picked this one, I just picked it. So if I look at this 1/2, and it takes one of these to make a half of this hexagon, right? It takes one of them to make 1/2. Then it takes two of them to make 2 halves. And then I'm thinking about size here. So if it takes one of these to make a half of the hexagon, how many of these? Does it take more or less to make a half than these? It takes more, right? It takes 3 of them. So what's the rule here? What are we learning? We're learning that as the fraction parts get smaller, right? A 1/6 is smaller than a half. As the fraction parts get smaller, it takes more of them to make the same amount. Yeah? So this one, it takes 1, 2, 3 to make a half. And this one, it only takes 1. Why? Because sixths are smaller than halves. Halves are larger than sixths. So again, you can go to coolmath4kids.com/manipulatives pattern blocks, and you can practice what I just showed you, but you can do it virtually on that website so that you can see what I've seen. And that's it for this part. This is actually going to be a 2-part lesson. So this is fractions part 2, lesson 1. And I'm gonna come back with a part 2 for this lesson. There's gonna be another part, but we've run out of time for today. So I wanna say thank you for watching, and I'll see you next time.